Oops. So now we got case 4. The degree of P, the numerator, exceeds the degree of Q, the denominator, by 2 or more. So it'd be like if you had, say you had x cubed minus 1 over x. The degree on the top is 3 and the degree in the denominator is 1. That would be one of these. Or x to the 6 plus x squared over x squared. That would be like this as well. And the way you do these, for these you don't get asymptote. An asymptote is always a line. If there's an asymptote, it's a line. With these you don't get lines, but what you do get is a function that f approaches. So we say f approaches the graph of some polynomial function s as x goes to plus and minus infinity. I just used s for some reason. And we say f approaches s asymptotically as x goes to plus or minus infinity, and it'll approach the same function. And the way you figure out that function is long division. So here's my example. X cubed plus 2x squared minus 4x minus 8 over x minus 3. Notice the degree in the numerator is 3. The degree in the denominator is 1. So the degree in the numerator is 2 more than the degree in the denominator. So when I divide, my first term is going to be an x squared term. And that's why it's not going to be a line. Right? So you divide, you get an x squared. You multiply that by x minus 3. Subtract that. You get 5x squared, bring down the minus 4x. Take 5x squared over x, you get 5x. Multiply that by the x minus 3, you get 5x squared minus 15x. Subtract those. Remember, you're adding 15x, so it's 15x minus 4 is 11x. Bring down the minus 8. 11x over x is 11, so plus 11. Multiply 11 by x minus 3. 11x minus 33. Subtract that. You're subtracting a negative 33, so it's plus 33 minus 8, which is 25. And then you would get plus 25 over x minus 3. But that part's going to go to 0 anyway. So what happens is you get this function just written in a different form. X squared plus 5x plus 11 plus 25 over x minus 3. As the magnitude of x gets large, that is, as x goes to infinity or minus infinity, that last term, 25 over x minus 3, goes to 0. So f of x goes to the polynomial part. And that means, right? So that means if I graph that polynomial, x squared plus y equals x squared plus 5x plus 11. Well, first I did of course, the x minus 3 gives you a vertical asymptote of x equals 3. So I graph that first. Then I graph y equals x squared plus 5x plus 11. That was my quotient here. My quotient with a y equal to it, right? Y equals this. And then you'll see, if you graph it on your graphing calculator, you'll see that your graph on both left and right side approach this curve and this line in the middle. So it looks like that. See? So it's useful. I think on most of the problems on the homework, it just says you would just put no asymptote. But I think this is useful to know because it tells you like what is the shape as you get away from the origin. As you get away from the origin, it's really shaped just like y equals x squared plus 5x plus 11. So in fact, say you were doing some engineering things, as long as you keep track of your tolerances, your degree of error, you could simplify this instead of using this rational function. If you know you're using large values of x, and they don't even have to be that large, as you can see from the graph, you could just substitute this polynomial and use it instead, as long as you're not near the origin, right? Like say you're dealing with thousands or something, and it wouldn't really make much difference.